Okay, so nice to meet you guys. Oh, I shouldn't say nice to meet you guys. I mean, I could say, but in Texas, especially southern part of United States, we say howdy.
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 Informal greetings
More
that we
things.
say hi to others, especially when we have a
Others.
seminar or classes. At the beginning of them, we say howdy.
Howdy,
All right, and
y'all.
I am
Oh.
Won Zhang. I work at the Texas A&M University here in Texas in the United States. I'm going to talk about what we as me and the Chehi Park, we did for the past semester here at the Texas A&M University with the electrical engineering students. And the title of the talk is When Engineering Minds Meet an Opportunity to be Creative. Small title is going to be a preliminary study on collaborative 4D frame projects with college engineering students. Jae Park, she is a researcher in a Department of Education at the University of Illinois Urbana-Champaign. She gave me a lot of advice and then did a lot of curriculum development for this project. So if Jehi, you there?
First, I'm here.
You want to introduce yourself?
Yes. Okay. Yeah. The experience
Can
and
you-
also.
We can hear you.
Yeah, we can hear you fine.
Oh. All right. Okay. So I just keep going. Can you?
Keep.
All right. Thank you.
Yes, we see you.
So my research areas always immersed around language and also linguistic creativity. But then when I was able to meet 4D frame, and I'm still investigating how to actually incorporate 4D frame, like which is a STEM tool, with the language and language curriculum. The curriculums for language are actually classrooms. But then I also wanted to see how 4D frame, works with, advanced levels of engineering classrooms from, a person closest person in my life, Won Hyuk Dang, who is my husband. So that's how we end up talking a lot about 4D frame and expanding the ideas each other at this moment. The initial ideas started from me and Dr. Hooger Park, Park Hooger 소장님. However, since Dr. Zhang was able to recruit volunteering participants for this for 4D frame, and also he made actually this project make it happen. So today I actually let him talk all about actually what he has done from this semester, particularly this semester. So all the data is actually very fresh, new, and very kind of hot. He just actually finished collecting all the data from his course, which was done last week. Was it Tuesday or Wednesday?
It was last week. Yeah.
Last week. So definitely we are still in the process of analyzing a lot of data, particularly qualitative data as well, but which actually should go most of me from my reflections. But today he will mainly talk about how students really studied the project with the 4D frame, who are never ever known about these tools and also who had never ever had any opportunities to participate this kind of experiences, but then how actually they end up the journey throughout the semester. So yes, although thank you for including me, Dr. Zhang, for your presentation at this moment. But yes, please go ahead. What you've got from your students and from your classrooms.
All right. Thank you for the kind word. Okay, so I'm gonna share my screen again. Do you guys see my screen, the slides?
Yes.
Yes, we do.
Okay. All right. So let's start. All right. So when, where, who, and with what? So here at the Texas A&M University in the United States, I teach. Actually, I taught one senior level power systems course in electrical and computer engineering. By the way, I'm a teaching professor and a research engineer here at the Texas A&M, and I taught this power system senior level course with what? So I used 4D frame toolkits generously supported by Hogar Park, and also we used microcontroller starter kit called Uno starter kits for electric circuits. As you can see here on the right, so this part is going to be the 4D frame that I used, or my students used, and the lower part is basically the kits that we used for building electric circuits. So this circuit consists of breadboard, microcontrollers, and the LEDs and resistors and all sorts of electric components. Right. So justification for this 4D frame project that we have done in the college level. I know that a lot of the times that the 4D frame related projects or events are mostly with the students aged between elementary schools to high schools. I wanted to, and Ms. Park, Dr. Park wanted to know if we can use these 4D frame toolkits with the higher level students, such as college level, especially with the engineering students who you may think should know a lot about how you're gonna build something and incorporate with the electric components as well. But the limitation in reality is a little different from what you can imagine. So limitations in the current curriculum, especially in college engineering, set up here at the Texas A&M is we do have students hands-on experience opportunities for the students to have before they graduate. The two categories. The first one is going to be the labs associated with the courses. A lot of engineering courses have associated labs. However, the problem with the labs is students have to follow the instructions written in the lab manuals, which is good for the object of the labs, but the problem is they don't have any freedom to do what they want to do. The second category of hands-on experience that the students can have before graduation is something called a capstone project, which is a senior level graduation thesis project, which is a year-long class with a project assigned based on students' resume, not chosen by students themselves. So basically what it means is there's no opportunities for the students to do what they want to do until the graduation. So when I talked about this to Jay Park, and let's have a project with your own course, which is a senior level power systems course, with the 4D frame related project that we can have a little more innovative curriculum, not just stick to the decades old syllabus. which can conceptualize ideas of students, and which we can give the students an opportunity to realize their imagination to nurture more creativity. For the students, if they can do a project from the beginning to the end, such as choosing the topic they want and all the details related to the topics of the project, what if they are given those chances? Is it going to be better in terms of what they learn from the class? If they can apply what they learn in class and they can apply to what they want to do in a hands-on project, is it going to be a better curriculum? Then our project started from the beginning of this semester. All right, so this course is a senior level power systems course. It has its own syllabus that I need to stick to. So this project has to be an extracurricular activity. So I need to recruit the volunteer students for the 4D frame project. I gave about 3 weeks at the beginning of the semester. I used this Google Forms to recruit the students, and then these are the 9 students who participated this project for the semester-long 4D frame project. And then some of them were friends to each other, and then some of them are not. So eventually we have 4 teams of 9 students. And as I don't know if you can read this here, the reason for why they are interested in this project is especially for those who are in second semester seniors, they started their own capstone project from the last semester, but because of the pandemic, all the thesis project, the capstone project was all online. They couldn't have any hands-on experience. For some of them, like half of them were excited about having a hands-on experience. The other half was first year thesis project, and then they have their own capstone project going on along with this 4D frame project. But the choice of the topics were given by the instructors of the capstone project, so they didn't have any choice. But here, they could choose what they want to do, so they are very excited about this project as well. Right, the procedures. So my role as the instructor of the course, I worked as a facilitator and the director of the project. Also, when I was recruiting the students, I told them that the project grade will replace the final exam grade. So I had to evaluate their performances and then their feedbacks and how the level of completion of the project to give them the final exam grade. Also, Ms. Park's role was basically curriculum developer. I'm an expert. I know the technical details of what they make with the different, but I'm not an expert in terms of curriculum and how to make it better. So Ms. Park helped me a lot in terms of making more students friendly, and then how we imply more comprehensive and collaborative project throughout the semester. So procedures we took is basically we start with the brainstorming and then sketch of the initial ideas and researches of literature reviews of the topics they chose and discussions of how we proceed with the project and organizations of the roles and then how they go with the project and then building the 4D frame as the structure of their product and also making the electrical components, electric circuits, and analysis, modification, and then demonstration and the presentation at the end of the semester as a procedure. So facilitating so as a facilitator, what we wanted to do is to make more of a collaborative work environment. and then try to give them an instant feedback from whenever we have meetings. So basically, we had two categories of meetings. One, a virtual meeting through Zoom on Wednesdays, almost every week, which is for I and the Miss Park get to meet for each team for their own collaboration within among the team members. So each team meets with me and Miss Park for about 30 minutes every Wednesdays. And the students, they report what they have done based on the feedback from the previous meeting. The in-person meeting was done on Fridays. So for the in-person meetings, all 9 participants meet for about an hour, and each team talks about their progress, challenges, and then possible solutions as a next step. And other teams provide feedback and comments. After other teams provide feedback and comments, I also add my comments at the end as well. So we had these 2 meetings almost every week for the semester. So I'm going to, what I want to show, this is college level project involving 4D frame, which will be, I think, different from the most of the project, 4D frame related project so far. So these students in a course, they do not each other in general. Some of them know each other. So basically, these people in the team named airbenders, they didn't know each other. They came to the project individually, and I made them as a team. The other 3 teams, they know each other, but not all the other teams. So the first meeting, in person, what we need to do was basically ice breaking. We need to introduce themselves, make them introduce themselves, and they had to choose a team name. I told them to come to the meeting with a brief idea of what they want to do with the project. And these team names are closely related to their project ideas, which I'll be talking about in a next slide or 2. And also, I wanted to give them a chance to taste what's 4D frame like. So, according to the discussion, conversation with the Hooker Park, I think, and Miss Park, and then I said that the Sierpinski triangle is gonna make a great example as an introduction to these college level students. So as you can see, these people are trying to make triangles. At the end, each triangle from the 4 teams make a bigger triangle. So they were very happy about it after this. So after the first kickoff meeting, next week we met again. I told them to come up with the details of the initial idea of the project they want to do, and then the condition that I gave to those students for this project was the theme. Since these students were recruited in a power systems course, the theme of this project has to be something related to power and energy. Another condition for the project was they should have moving parts in the final product. As electrical engineer, not the civil engineer, I wanted to have them to incorporate what they have learned as an electrical engineer, such as electric circuits, as part of as a moving parts in the product. So 4 teams and their initial ideas, they were talking about their ideas, sketching on a whiteboard. The very first team, Helios. Anyone heard about Helios? It's a Greek word meaning as a sun god. Sun god, as you can say, that it's related to solar. So what they wanted to do is solar tracking device. The second team is flinkings. So flinkings is basically they wanted to make a catapult using wind power. So they were drawing on wind power, wind turbines connected to a motor here, and then they want to have a wheel, and then they want to have something to throw a stone or an object as a catapult. And the third team was airbenders. Airbenders is basically the name from a famous animation. I forgot the name of the animation. The anyone remembers the
Avatar.
Airbender?
Avatar and the last Avatar.
The Avatar and the last Avatar.
Avatar. Yes, Airbenders came from Avatar. And then what they want to do is basically airbenders. So they wanted to use wind power application to use at home. And then the last team name is make it or break it. So basically, they wanted to make a circuit breaker. So the course that I teach is the power systems course, which is, the name of the course is the power system protection and fault analysis. In which I teach them how a power system circuit breaker works. So when something happens in power systems, when we have a fault in a system, we're going to isolate the faulted part by operating circuit breaker. So they wanted to implement circuit breaker with the 4D frame. That's why the team name becomes Make It or Break It. All right, so we wanted to give them a comprehensive experience throughout the project, not just making and building stuff with the 4G frame and the electrical components. We wanted to have them the knowledge of the topic they chose from the invention to the current trend and including the near future, vision in the near future. So what the first team, Helios, did was they actually wanted to make a solar tracking devices, and they came up with what are the current trends. So basically, there are a fixed mounting type, which is here, and there is a single axis. So basically, solar panels going to tilt forward and backward to follow the sunlight, and there's dual axis trackers, which can do the solar axis, single axis can do. And then it can spin left and right. So basically what they say is the most used type is the second one, single axis tracker, which is more economical than dual axis. And the efficiency of getting the producing the solar power is not that less than the dual axis. That's what they studied. The airbenders, what they were doing, the literature review, they actually changed their mind, and then they changed the topic from the wind power application for home use to wind power comparison. While they were doing the literature review, they found that actually there are two categories of wind turbines, which is horizontal one, which is what we usually see in the field, especially in Texas and Midwest in the United States. And there's another type called vertical axis, which is not that used a lot. And then they wanted to know why there's a difference and why the one is more dominant than the other. So they wanted to do the wind power comparison. Third one also changed their plan while doing the research review and also meeting with me and Dr. Park in a previous Zoom meeting. So they were initially wanted to use wind power to create a catapult. And then they realized that, what about the vision of the catapult in the near future, which is like close to none. And then they wanted to keep the idea of using the wind power, but they wanted to be more practical. So they changed the direction to have, what about how we use wind power in the near future, where all the power source is going to be renewables. And if we're going to use wind power in our very high, tall buildings, typically wind blows harder at a higher altitude. And then what about we use those power from the wind to use something for those tall buildings, such as an elevator? And I thought it was a pretty brilliant idea. And then they said, okay, I'm going to go with this plan. And then they started to talk about the wind power with the elevator. The last one, make it or break it, they worked about the a circuit breaker from the invention to the current status of the circuit breaker in the industry. So so this is, I think, the third meeting in person Zoom. First progress report. Helios, the solar tracking device for educational purpose. The one on the right here is their sketches of the initial ideas. They came up with 3 ideas. Basically, what they wanted to do is, the yellow one is the solar panel. And for them to track the sunlight, they want to use photoregisters at each of the 4 corners, here, to detect where the sunlight comes from. Photoregisters, basically, if they have the lights, the resistance goes down and they can produce more currents out of it. So basically, these currents as signals, go to the microcontroller, and then microcontroller decides which location out of 4 corners have more lights. And then they're going to produce a signal to these 2 motors to rotate the solar panel to the light. So they had 3 ideas of how to make these, where to locate motors, and then it seems to be they came up with they followed the idea 3, where they have the motor at the bottom for turning the solar panel left and right, and one at the top to tilt it forward and backward. So these are the very first, I think it's not even first, it's the second or third versions of the bottom part with the motor and the top part with the motor. And this part is going to be the solar panel housing. Second one, team, the Flinkings, basically they wanted to use wind part for elevator. This part is the elevator housing. And then they're going to use a turbine connected to the generator. And then the power produced by the generator is going to energize the motor to lift up the elevator or down. And they're going to have 3 switches for each floor. Basically, the first floor, second floor, and third floor. So their initial progress report, they said they made wind turbines connected to the generator. Third team, the airbenders. So what they wanted to do was to compare the vertical and the horizontal axis wind turbines. Basically, they have to have 2 types of turbines connected to the generator, and the power generated by the wind is basically AC source. But they wanted to use it for not just to compare the how much power is produced by vertical and horizontal. They also wanted to use it for some sort of usage at home. So they need to convert it to DC to light up the LEDs. They're going to have a house later with the LEDs to use the power generated by this wind. So they have classical horizontal axis turbine and vertical axis turbine, and they were testing the different angles of the wind turbine blades as well. So last team, make it or break it. Basically, they want to make a circuit breaker. As they learned in my course, they wanted to have 2 towers. And the circuit breaker is going to monitor the voltage between the transmission line and the ground. If there's an abnormal voltage measured, and that measurement is going to be detected by the microcontroller, and the microcontroller is going to give a signal out to the motor and the gear to open up, basically trip the transmission line there. So they were testing microcontroller and gear system, saying that green light, if we have a green light, it's a normal state, so do nothing. If we have a red light, okay, there's something wrong with the power system, let's open up the transmission line. Just like the power circuit breaker does in reality. So, as I said, Ms. Park and I wanted to make this a comprehensive experience, not just to make something with the Polish frame. So one of them is we wanted to make them to make an introduction of a video of introducing themselves. So one reason for this is, especially Ms. Park can add if you want to, but he wanted to give team members, which only a few of them know each other, not the other team members. So they only need to know each other as a social interaction between all the participants. Also, most of them, actually all of them are seniors. Making a video of introducing themselves will be a practice for the interviews that they're going to do in the near future for job hunting. And then basically while editing this video, they'll see their faces and then what they say in an interview. And it's going to be beneficial for them as well. So maybe I can play like about just 30 seconds of one of those videos. Do you guys hear the sound? Wait.
No, sorry, we can't hear the sound.
You might need to share it again with audio.
Right, you need to
We
share
can't
screen
hear.
again.
We can't hear.
The sound doesn't work.
I think you have to share screen again and just check the share audio feature.
I don't think he can hear what we are talking now. Should I make a phone call to him? He doesn't even look at.
Do you know what he's saying at this moment?
Yes, because I gave what to include. So about them, of course,
All right. So I had all of them making their introduction videos, and some of them looks very nervous, some of them are more natural, but I think it was a pretty good experience for them to make their own introduction video of themselves. This is some of the clips that from the Zoom meeting with Dr. Jae-hee Park and me and all the 4 teams, and they were basically briefing Jae-hee Park what they have done and then what's the next step, and Jae-hee Park was giving them feedback in terms of how it more in terms of educational aspects of what they are doing in a project, that kind of stuff. And this clips of the, I think, 4th in-person meetings. So as you can see, there's a little bit of improvement in terms of Team Helios. They ordered the solar panel, and the solar panel finally got delivered through the mess of the chain supply, if you know any. But so they were testing their solar panel with the breadboard and their motors and the motors in the top and bottom part. for the flinkings. Now they came up with the elevator system with the 4D frame, and then make it or break it.
오디오 소리가 아예 안 나고
어.
우리 말하는 거 안 들려?
안 들리는데?
우리가 말하는 것도 들어야 되고 자기 메시지도 체크해야 돼. 줌 메시지. 줌에 있는 메시지 있지? Always keep an eye on the
Yeah.
And also you have to hear for Q&A.
Hmm.
Q&A. Okay?
All right. I'm so sorry. Can you guys hear me now?
Yes.
Yes, we hear you all the time. It was the
Hear your
film we
voice,
couldn't hear.
but
You see,
I can hear you, not your video.
the speaker option automatically goes to something else that blocks me to hear what you say. Now I have to choose the option that I can hear you as well. Anyone had a question so far? Yeah.
No questions so far. We were just struggling to hear your audio on the video portion you were just showing. So everything's been going quite well.
Yes.
You can resume where you were.
Again, it goes to the previous setup. I don't know why it changes to. Now I can hear you guys.
We have videos, more videos, right? So please check with us if there is audio.
Okay, so
There's
I think
sound.
We are running about 15, maybe 20 minutes left.
Okay, so I think I'm gonna go this way so I can see your reactances, chats as well. So so basically, this is the improvement in third and fourth in-person meetings. The Make It or Break It came up with new transmission tower model, which is more rigid to stand steel compared to the old one on the right. And the airbenders came up with the different types of turbines. Also, they made a small house that they can light up. The LEDs inside, eventually using the wind power they generate with those wind turbines. So, of course, there are challenges each team faced during the project, and the main challenge for the two teams which used wind power was basically, wind power application. You need to have the wind turbines to spin fast enough to produce large enough power, which was not really happening almost half the project period for these two teams. So both of the teams were facing actually the same issues. Flinking's large amount of wind power is being lost due to the turbine design and friction. That's what their analysis of the cause. The airbenders think the speed of the turbine is too slow due to friction. So basically they're doing the same thing, having the same issues with the wind power application. So the initial solutions were actually different between the two teams. The Flinkings used cardboard to increase blade dimensions, basically increase the dimension of the turbines using cardboard, or the connection of the turbine directly to the generator to eliminate friction. The second team, the airbenders used different turbine design to capture more wind. And what about eventually both of them were trying to use the hair blower for the wind turbine spin. What about we use something else other than hair blower? Higher blowing power source. So, but eventually their final solution is the Flinking used a different generator with a different specs, so they had enough power out of the generator. The airbenders added a gear system actually, which is true in reality too. Most of the wind power generations use a gear system because wind turbines can spin fast to be stable and reliable operation, and they have gear system in the back. The other two teams also had the challenges, and then they try to analyze the cause, and they try different solutions. And they came up with their own solution at the end. So Miss Park and I wanted to give the guidelines for the final deliverables for the course grade. Basically, we wanted them to make 2 video recordings. One of them is the marketing video. Basically, we wanted them to make a video like a advertisement in a TV show, which showcases how it works in an appropriate setup to connect your product to real situations and necessity in the future. Second one is basically that incorporates the complete procedures of the project from the beginning to the end, including justification, literature reviews, sketches, part list, everything. And then the last lecture date, we had a presentation and demonstration in class in front of the classmates. 3 minutes of marketing video, about 10 minutes of presentation with slides, and 2 minutes of demonstration with their product. So I'm going to show you a few slides from each team. So this is Team Helios with the solar tracker. They explained their initial ideas, different ideas, 1, 2, 3, 4, the location of the motors here and there, and the wiring diagram for the microcontroller to the breadboard for the voltage measurement, and the motor control wire diagram here as well, and part list, what they have used for their product, and then different types of bases and the top parts, and then basically this is what they have made as the final product, and the test and validation. So this is going to be a marketing video, so which is not going to be too long. I'm going to have half of this. Let me know if you guys can hear the sound. Can you guys hear the sound?
We cannot hear it. So, Dr. Zhang, it might be best if you stop sharing and then reshare, but click the button that says Share Computer Audio when you go to share screen.
Yeah, I found it. All right. What about now?
Not yet.
Wong Jung. Có điều là mẹ Wong Jung.
Now we can hear it.
Okay, cool. All right.
But now we can't see anything.
I can't see the video though.
Or here.
Can't see the video?
Okay.
No, we have a blank screen.
Can't see the screen?
Nope.
Green.
What's wrong?
It's the gremlins. Zoom gremlins.
Do you guys see this?
No, sir.
No.
No
yet.
screen.
No, we still have blank screen.
Okay.
That's okay.
Okay.
Can you
Then.
go
Yeah,
back
I'll
when-
skip the video part then.
We are happy to listen to you.
Okay, sorry. All right then. The Flinkings, basically they try different turbine designs. Actually, they bought a new generator to produce more power out of the wind turbine. And so they try different, expanding the turbine dimensions. They try to use the different components for the turbines, but eventually they use 40 frame that produces enough power for them to lift up and bring it down the elevator there with the first floor, second floor, and third floor elevator system. So these are the circuit design and the microcontroller design processes, and then some of the codings they made. Let's try one more time with this video. If it doesn't work, then I'm not gonna try anymore. Let me know if you can see and hear this.
Yes.
No. No, we do not see or hear.
화면이 아예 안 보여요. 파워포인트 화면이. 그냥 파워포인트 보여주세요. 아까처럼.
Alright.
파워포인트 그 보여주세요.
There we go.
One last time.
안 되고 아까처럼 파워포인트를 켜주세요.
Do you guys hear and see?
We see the film, yes.
Nicely done video.
Yes.
San Bernardino.
Well, I have a question. What is the platform you are connected to? Is the Arduino is connected to this white one? What is it?
Oh, Arduino is connected to the the breadboard, actually.
Yeah.
So they can have, and they're going to basically harness the power from the hair blower wind energy from the 40 frame wind turbines, and then they're going to make the motor to run to lift up and down the elevator.
Nice.
And then there's going to be a switches here saying first floor, second floor, and third floor. So it's basically an elevator system using the wind power.
That's great.
Beautiful.
Right. I'll go to the next team, which is airbenders. So basically, they tried many different types of turbines for vertical axis and horizontal axis, and they compared how much power they can produce with these two exact turbine mechanisms, turbines, but the different axis mechanisms. And then the conclusion is kind of obvious, that the horizontal has higher efficiency, but requires more space and more noise. But vertical axis, even though they have less efficiency, capturing less energy from the wind, but it needs less space and less noise. So what they say is it's gonna be more popular in the near future if wind energy has to come into a dense city. And that's their presentation. They're trying to be a Texas look, trying to sell their product, with the hats and that kind of stuff.
Mm-hmm.
And then make it or break it is basically they're trying to have a solar tracking system, again, with the Arduino, with the voltmeter from the light sensors, a signal from the light sensors. And then they try to make a transmission tower or the base, and they had the different types of the transmission towers and then the logic gates they use for determining the normal state and the faulty state in the substation design with the servo motor that make connections and disconnections between based on the situation of the transmission line. I'll skip it as well. So feedback from the participant about the 4D frame. I guess this is more for the Hogel Park. This is what they felt from doing this project, saying, what if we had more angle connectors? What if we have option for wire management and more rigidity or more flexibility, like throws like here? What if we had something like a board that we can put all the components of the 4D frame fixated so it doesn't blow away when using a hair blower, that kind of stuff. And then an acknowledgement, I have to thank you for 4D frame and Hogel Park to support the 4D frame toolkits. Also, I used the Tamu IEEE Lounge for the support for the Arduino kits. Thank you for listening to my presentation. Dr. J. Park, do you have anything to add?
Next time, let's check audio for sure.
Yeah, I'm sorry about that.
Sorry, yes.
First time, so yeah.
That was very interesting. Thank you. I haven't seen any particular questions in the chat. I don't know if any of the audience have any questions now. You can just put your microphone on.
I got a question.
Yes.
Where do you regroup to do that? On your house, or you get a school that gives you an area, or a public, let's say like a community area in your place, when you congregate everything together, or it's like affiliated with school place?
I reserved a conference room every week for an in-person meeting on Fridays through the department. They're all electrical engineering students. So.
But also we asked questions like how many hours they had to spend in total, and we actually found out that they met in cafeteria and at home beyond the weekly meeting that we actually set up, just 4 hour actually facilitating. But they a lot of them actually end up spending up to from 35 hours to 50 hours to make this happen. So we see that, but our meeting was only maybe let's say about like 10 hours probably, just spent with us. So beyond that hours, I'm pretty sure they found a space, maybe their dormitory or cafeteria, or their, Texas A&M has a lot of actually spaces for meetings, and just to let you know.
I have a question, if I may.
Yes.
How would you assess the students' prior experience with actually building and sort of tinkering and learning by getting their fingers on things, and how did this event change their perspective, or this experience change their perspective on what they think they know?
So I can answer the first question. The second question, I think, should be answered by Jae Park as a research on education part. But the first part, basically, these are the senior students in electrical engineering. So as a professor in electrical engineering department, I already know what they have gone through, what courses they've gone through, and what kind of capabilities they know, because they have to go through a certain courses, mandatory to graduate. And I know that all of them should have experience of making electric circuits using microcontroller already. That's why the condition that I gave you was you got to have a moving part so they can incorporate what they have learned throughout the undergrad program period into the 4 different projects.
So, but they've done some actual construction of parts, components. Okay.
So this time we just have to accept, anyone because, it's extra curriculum that we actually made this as our preliminary kind of approach as well. But also Dr. Zhang and I did not know, how many will eventually participate in as well. But throughout the actually procedures and processes, actually, I actually thought about similar things like Chris, like you say. But good thing was, first of all, even though some of students were exposed to maybe Lego, their own culture, cultural maybe experiences or cultural interest, but some of them are actually not really. Some of them I can see that even collaboration is in their development, and also even crafting is also experiences that they are developing as well. So I was, as an researcher and also an educator, I was able to see the actually levels of pace of how they are actually moving forward, according to, again, like background, according to their research directions, and also according to their personality. But fully framed, for sure, it was very first exposed to everyone, and from the beginning, 4D Frame actually provided initial this equal starting of exposure, and also how they are actually how they had to make it come through by talking to each other, relying on Dr. Zhang, who is an instructor as well. So that was actually bonus, but like you say, because of different experiences from culture and also exposures, we were able to see actually how some of them are very enjoying from the beginning to the end, but some of them are actually they did not know what to do in terms of collaboration and in terms of finishing up the product. So we had to actually push them a lot, but a lot of them actually liked this experience so much, and they are actually registered another course that Dr. Zhang is going to teach, which is capstone project he's talking about. And a lot of them were asking can I still use 4D frame in your classroom again? So at the time, hey, actually we can have actually group that, 4D frame expert at this moment, because some of them are experienced already, and we will actually give you a harsher evaluation since you are already exposed. But you can be a kind of leader of 4D frame as an advanced group to introduce maybe another group that who will be exposed, who will have a first experience with 4D frame if they volunteer again for this task and project. Mm-hmm.
We had we don't have much time left, but we had a question from Philippe here about there might be more people interested in the answer, what the device was, the TAMU device you've used to for this platform.
So it's yeah. So basically, it's a microcontroller starter kit called Uno Super Start Kit. I was supported this time. We were supported by the IEEE student branch at the Texas A&M, but they are actually you can buy it at Amazon for less than $40. for they have different stepper motors, different motors, the microcontroller breadboard, and then all sorts of different control electric components and the cables. So it's pretty decent toolkit.
Nice.
To make electric circuits.
Interesting to see engineering students using the 4D frame as well, because they make slightly different things, don't they?
Mm-hmm. Yes.
Any other questions? Otherwise, we perhaps need to move on to Steve Sherman. No?
No.
Okay, Steve. Sorry, Chris?
No, I think it's best we move on. Well,
yeah, we move on. So, Steve, the floor is yours.
Thank you so much. Hopefully, I won't have too many presentation issues because I'm not going to be doing a PowerPoint. We're just going to be chatting. And what happens is when you listen to other people's presentations, you start to develop a whole bunch of ideas. So I've just added a few extra things in that were not included in my presentation, and they will form part of my presentation. So by way of introduction, my name is Steve Sherman, and I'm the Chief Imagination Officer and Executive Daydreamer for a STEAM-based NGO called livingmaths.com, and we put the S at the end of maths. And we like to think that we are going out there as the custodians of STEAM, and we are passing on our passion to young students to get them excited about the possibilities of STEAM. And there are so many wonderful things that we love about STEAM, but there are so many misconceptions about STEAM. And I wanted to just touch on a few of those. But I do want to say that Dr. Jang and Ms. Park, your presentation was absolutely fascinating. And I'll tell you why. I loved watching the various interactions of how your students' projects moved from an initial concept to a final project, bearing in mind that they chose to do this. It was not because they were forced to do it. And that is very important. I like the fact that obviously they started off with some interesting ideas and bold ideas, and then the feedback loop came in, and all of a sudden they started iterating and changing their projects to match the real world needs. And I think that is very important, that feedback loop helped them to refine and appreciate that some of the ideas they had were good, but maybe they didn't fit into a real world context. And you started to see how those projects evolved and developed. And of course, it certainly allowed us to see an introduction of STEAM where we actually touched on some of the 4 C's, which I will mention a little bit later on in my presentation. But the one thing that I needed to show you is a video. And that is because when I watched these wind turbines, it reminded me of the day that, well, for many of you who don't know, there's a wonderful program on the internet called Global Cardboard Day. And it originated from a young boy who was making cardboard box arcades in his father's workshop in Los Angeles called Kane's Arcade. And this young man, he built the most elaborate arcade you've ever seen. And of course, it's got the most beautiful games, the hook machines and all those things you could ever imagine at an arcade. But he never had anyone playing at that arcade. And along comes Nirvan, a friend of mine, who is also a film maker. And he actually films this. He thinks he cannot believe how such a young, smart young man has built this incredible arcade and no one has come to play at the arcade. And eventually what happens is he posts this on Reddit and a whole bunch of other forums around Los Angeles, and he brings out the whole of Los Angeles to come and play at this arcade. Now, what sparked this enthusiasm led to far greater things. People were so impressed with Cain and his ingenuity that they actually started raising money towards his college fees. And once they had raised enough money to cover all his college fees, bearing in mind he's only 9 years old, they had a surplus. So what do you do with the extra money? They launched the Imagination Foundation. And the Imagination Foundation started building chapters around the world. I had started the first one in South Africa. And effectively, we were bringing kids to use their creativity, their imagination, using some STEM, some STEAM, everything that you can imagine. We put them all into these weekly meetings that A, were free. So children did not have to pay. And B, the children chose to come. They were not forced to come. And what resulted was some incredible stuff. I won't go into all the projects, but I do want to show you a clip, because what happened was Google found out about our imagination chapter, and they sent us not only a film crew, but they sent us a big parcel. And in the parcel were arts and crafts equipment, Arduinos, light sensors, cell phones. We got these beautiful cell phones. I even have one over here, these little mini cell phones. And there was a new app that they had developed called Science Journal, where you have to document what you are doing in your project, and you can take photographic videos and whatever. But what's also nice is that the Arduino can connect via Bluetooth to the journal, and all the readings that your Arduino is picking up, it can then store that on the journal, and it makes just your reporting a lot easier. So I'm going to show you a quick little video. I might fast forward the little bits, but you'll get a sense of what young kids under the age of 10 will see. And I know that Philippe has to leave soon, but he wanted to know about, teenagers using Arduinos. I think this would certainly interest you, and watch how the problem solving evolves for this particular project. So let's go like this. We're going to share screen with audio. Hopefully you can now all see my screen. Can you? Do I get a thumbs up? Yep, okay.
Yes. And we hear it too.
Perfect.
Fun things like play fun games.
This imagination thing, it's quite fun.
We get young kids to meet here every Monday to explore their creativity. They get to make things, they get to break things, they get to engineer things.
What is science?
Well, there's many different kinds of science. There's natural science, it's not only one thing. Natural science is my favorite. It tells you about the world and plants and animals and ecosystems.
Remember, you always turn to your right, righty-tighty, loosey-lefty.
What is science? It is when you mix chemicals, like a blue potion with a green potion, then you can make like an explosion.
They're trying to figure out discoveries that will help the human race.
I think that science is really an investigation about the world around you and how things are working. The Science Journal app is really kind of like a sidekick that allows you to measure things that you might not have been able to see before.
The partnership with the Making and Science team at Google has given us an opportunity to explore big questions in some really unique contexts. We get to travel the world to see very distinct locations, try out this new Science Journal app.
Did your wind spinner work?
No. It was rigid and it didn't want to work. So I felt like I could do better. Then I started modifying it. I think we're going to do good with this.
Go, 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 go. Let's see, what's it going to go up to? You made 70s. It's going up to 100, 127. So you are 190, 207.
Is that your favorite color? Perfect. In that case,
The most important thing for me as a teacher is that I want to observe kids playing. If you go get kids to play, they are learning and discovering at the same time.
It was fun to work with people younger than me. It taught me patience.
Merry-go-round will be too big and will cause too much resistance against wind, so it won't spin as well.
First of all, what's resistance?
Resistance is when something goes against something else.
But if there's too much clumping, the weight will be higher. Let's try.
Good. Wait.
But what if the wind comes the other way? Yes. 0. Yep.
I think we need to build like a sport.
Yeah, because it's actually wonky.
Yeah, it's wobbling, which is not good.
The first thing didn't really work, so we made a new thing.
If you keep it so, the wind will blow it. So the thing can turn, but it's gonna go slower and slower. You need something light. No, stop. Just leave it. See, why would I hold the bottom?
Oh, look at this. Look at this. High five on that one. My greatest science influences are my kids and the kids that I teach, because I see real science happening in front of me on a daily basis, and that excites me to no end.
Well, it's so interesting how you can ask questions and then you find the answers yourself.
And I think that you get the gist of it, that they had to use the Arduino sensor because they had a small little disc with a hole. And as the wind turbine spun, the hole would move over the light sensor and it would record the number of pulses per minute. And that would tell you exactly how many times this device was spinning around. And then we could measure that using the app. And of course, you could just imagine the hundreds of thousands of ways you could expand a project like that with very basic and simple equipment. But what was fascinating was the learning journey, watching them start off and failing. And that did not stop them. And I think that that's what real STEAM is all about. That, you have to be used to taking a project and going through various iterations and enhancing and developing the idea, because I think that that is the best way for students to actually learn. So while I was on that, so Felipe, I hope that was something that you might find interesting for your teenagers. It really is a lot of fun, and the Google Science Journal app is available on I think most devices anyway. I want to talk about integrating arts into STEM. You see, there's this misconception that if you take the arts and you put it into STEM, then you have STEAM. And that is not the case at all. And when I say that, I mean, there are some people, teachers, who go, we're going to be doing a project about planets and space. So we're going to learn about the planets, which is the science. We're going to do the measurements of the planets, which is the maths. And then you're going to color in your planets, and that is the arts. That is not STEAM at all. That is just taking a little bit of art, adding a dip into your STEM and calling that STEAM, and that is unacceptable. I like to think that when we're talking about STEAM, that we are giving the arts an equal platform, that arts are not feeling like the long-lost step sibling it is actually a member of the family. And I will give you some practical examples of some STEAM projects where you're going to go, I see the complete integration of the arts and not just the afterthought, which is what some people do. And of course, why do we even need to include the arts into STEM? What is so significant about the arts that help us to make STEM so much better? Well, what we do know is that there is a strong link between creativity and the arts, and of course, technology. So then when you start introducing the arts into STEM to make it STEAM, you start adding a richness and a whole new higher order of thinking and problem solving and high concept design that start blending together. And when you have more creativity in the field, I think that we produce better results. And it's not just me. Go and ask Google. Google, for example, is very famous for conducting interviews with open-ended questions that are designed not only to show what a candidate knows, but how well a candidate might think on their feet and collaborate creatively with their peers. Not only that, but other technology companies have already started using creativity to get their employees to think outside of the box, whether it be Microsoft holding employee science fairs, to IBM's jams, and of course to Google's 20% time, where you take 1/5 of your time and you invest that in creative projects. And of course, all of these companies are using an artistic method to influence the creation of new technology or improvements to existing technology. And often from these breakout sessions, wonderful things emerge. And one very well-known example is a 3M employee who took their 15% time, which actually preceded Google's 20% time, by the way, by quite a few years. They took a failed adhesive at 3M and they put it at the back of a piece of paper. And that became one of their most famous products, known as the Post-it note. So sometimes the most incredible things will come out of creative play and experimentation. So I do want to talk a little bit about the creative process and why STEAM is of great benefit to all of us. And I think Sir Ken Robertson, the late Sir Ken Robertson, he said it very clearly. You know, he was talking about in one of his TED Talks how when we are at primary school or elementary school, we focus on doing all those wonderful creative things where we have art lessons, we are making things, we are designing things. But as we start moving towards high school, those aspects are pushed aside and more focus is given to the mathematics and the science and the more right-brained activities. And we stop moving with dance and art and music and plays because the focus is to get you to university. And that factory that takes the students and tries to put them into shapes and then move them into a degree. Unfortunately, I do not believe that that is of great value to us as a society because the world around us is changing at such a rapid pace that you cannot expect to take something that we've been doing for the last 40 years, put the students into that mold, let them come into universities and expect those people to cope in the world around them. I'm glad that we have innovative educators and lecturers like Dr. Jan and Ms. Park, who are actually saying, you know, look at what the university has been doing for 30 years. Surely there must be a better way. And introducing these passion projects, you will start to see, and the irony is you might not see it now, but it might come in a few years' time, when these students go and get jobs and they become the leads on various projects. And the question was, where did you develop all these amazing ideas? And they'll say, was this funny thing. We did this fun little project that we volunteered for at university. And that was what opened my mind to building this incredible solar array that we are now using to power our country. So sometimes it's those passion projects that actually open people's minds to the real world and what we can actually do with those things. So STEAM is obviously very important. It does teach you to think outside of the box because you are integrating the arts with the sciences. People can then start to feel safe to express innovative and creative ideas, because when art is involved, it's a little bit more messy, it's a little bit more interactive, it's a little bit more experimental. And I think that scientists, they do need a lot more of that kind of encouragement to be interactive, to make mistakes. It's okay to make mistakes. As you saw, our kids made mistakes, but they learned a fortune when they made those mistakes. You need to feel comfortable doing hands-on learning. When those students got their hands on those 4D kits, that is when it changed everything. And I think that, just telling people that you can build something and here are a few graphics, it's not the same as taking those 4D kits and actually putting the frames together and building shapes and realizing the limitations. And of course, that's why we got some feedback for Hogel and your team on how to maybe make these kits a little bit more versatile for university graduates, which I think is a wonderful idea. And of course, STEAM also gets you to take ownership of your own learning. You get to collaborate and work collaboratively with others. You start to understand the way that maths and science, art and technology, how they actually blend together, which is very important. And I always tell people I have 2 degrees. I have a science degree and an arts degree, which means I can write essays and do sums. And I think that, people laugh and say, well, what's the benefit of that? Let me tell you, I use my creativity and that creative side in 80 to 90% of the things that I do. And I think that that has given me the position and the strength to actually be bold and try new things that a lot of scientists are quite rigid about and say, listen, this is the limitation of the experiment. We're going to stop there. And you need to learn how to climb out of your comfort zone. Otherwise, you are never going to grow. So what I do want to add is that, of course, if careers in STEAM-related fields are all about solving real-world problems, then, of course, the STEAM classrooms should be no different. Giving your students problems to solve that have got no bearing in the real world, have got no social context, will often make them wonder why we are doing some of these projects. But when you gave them the theme of power and energy, and you said to your students, that is your theme, but be creative and bold, come up with your own ideas, that is when they chose their own destiny. And I think it is so important that if they understand there is a context, then they will choose projects that actually work. And I think it's very important that we need to guide students' projects by giving them a framework. And of course, you gave them that framework. They then use their design thinking and engineering design process to make whatever it was that they came up with. You also want to keep projects doable, because this encourages students to aim high while working on their projects. And of course, it also gives them realistic, achievable limits in terms of what their learning context is. And you've got to start close to home. Find problems on the school campus or in the neighborhood or in your state, because this is exactly what we want people to know, that the context of what we are learning has great value to the people that we are and the people that we interact with. And I think that any good STEAM lesson is grounded in inquiry, problem solving, process-based learning. In fact, I think that is, the distinguishing factor, the characteristics between just arts integration and STEAM, because you want to make sure that, of course, STEAM lessons, when they are being used, that the art content has not been just added in, but it's selected purposefully, and that it's being taught with integrity and not in service of the other content. And that is very important and non-negotiable. The art must never be in service to the other content. Many times we'll often see those examples of teachers who will give projects to students, and teachers will say, well, we are a STEAM-based lab. And I'll go, really? What project did you do? Oh, we did a lovely project on building hydroponics. I'll go, well, that is fantastic. And where did you integrate all the arts in your hydroponics? Well, the kids did a beautiful poster. And they did a beautiful poster with lots of colors. And you call that STEAM. Yes, because we put the arts into that STEM project. That is not STEAM at all. And I'm going to be controversial here and ask, can a STEM teacher also be a STEAM teacher? And in my opinion, in many cases, they can't. Because unless you have a skill in those arts, bringing it into STEM, unfortunately means that you are bringing in a lack of knowledge of that particular art. So let me give you an example. Let's say I think we should introduce photography into a particular project because we are going to be measuring the growth of mold in a petri dish, and we actually need to document the mold growth photographically. So all of a sudden, and Chris, that's a very good point. How do you define the arts? Remember, it's not art that we are introducing into STEAM. It's the arts. It's music. It's dance. It's photography. It is language. And the fact that, Ms. Park is busy working with integrating language into an engineering course, those are critical aspects of the arts to bring into STEAM. But, there are just so many actual issues that I have where teachers come in and will say, well, we're going to do photography. Now, the teacher knows nothing about photography. And yes, it's helpful to bring it in, but it's far more helpful for someone to come and coach the students in the subtle nuances of taking photographs, looking at photography over time lapse, looking at the different speeds and exposures of photography, because that's going to impact the findings of their mission. So I think it's very important that when we do bring STEAM into it, that we actually bring in the appropriate training of those STEAM aspects. And last but not least, very important, I think it's critical that you don't go and introduce students to concepts that they don't understand. I mean, if you are working with STEAM, you've got to work within their knowledge capacity. So yes, you can introduce ideas, but at the end of the day, they need the requisite tools to be able to do these things. So, if you are going to be doing engineering and you are going to be talking about breadboards, they need to know something about building breadboards and actually connecting the circuits. You can't just expect them to now start from afresh and pick up an Arduino and then here's the breadboard, go and draw me a circuit diagram, because they might not know what you're talking about. So it's very important that you also put them into that category where they are able to interact with things that they do understand. And one of the critical things of STEAM, in my opinion, are they call them 21st century skills. And they sometimes call them the 4 C's. I'm going to add a 5th one as well. There's collaboration, creativity, critical thinking, communication, and I'm going to add care, which is basically like empathy. And, a lot of people call these soft skills. Let me tell you, there is nothing soft about them. These are critical skills if you want to take the world by storm, if you want to get into a workforce which is changing rapidly. Collaboration, creativity, critical thinking, communication, and care, those are going to be your strongest skills because you have to work with people and you have to actually share ideas. And if you cannot do that, then you are going to fail. And what I found fascinating is, unfortunately, we didn't get a chance to see some of those presentations and videos, but some of those students learned not only how to make a project, but how to articulate and express their ideas. That is a very important language aspect. You know, science communication is critical. And I go to many events where I have people who've got doctorates, who are professors of departments, but can they explain a concept in simple terms? No, they can't. They understand it, but that doesn't help me. I need to understand it. So it's very important that we teach people on how to actually take your science and communicate it. If you are going to be collaborating with students and you are in teams with people you've never worked with, you saw firsthand people were thrust into a team. Now they have to learn to collaborate. That is what happens in the real world. You can't just expect to put everyone in the team that they want to be in. That is something that happens at primary school, elementary school, where the kids will go, I don't want to be with so-and-so because they never do the work. You know what? In the real world, you get put into teams of people that you don't always know. And when you climb out of your comfort zone, that is where you grow. So I've given you an introduction to STEAM education. What I do is, what I want to do is now give you some practical examples. And I think that some of these practical examples are really awesome. One of the examples that I'm going to share with you very, very quickly is, and hopefully it's going to load up here, because you never know, sometimes these things do misbehave. Here we go. I believe this is it. All right. So I'm going to share this with you, and I won't share the whole video. I mean, it's only 47 seconds, so you can watch the whole video, I suppose. But what I like about this is when you are bringing art into science, it's not just regular art. Now we are bringing art into augmented reality. And I'm going to share this video quickly with you. Let's have a look. So in Japan, they wrote this incredible app that you put onto your phone. You then use these Google Cardboard devices. And what it does is it simulates the dangers of events that could take place in your school or in your area. So let's have a look at some of this. So now, of course, the classroom is not actually flooded. What has happened is that the app allows you to view the classroom if there was a tsunami or a flash flood and the water level rose to a certain level. How would that actually physically impact your classroom? And if you walk outside, what does it do to machinery and equipment? Now, what would happen if you had a storm where these massive balls of hail were falling down and landing? I mean, you could be under risk. So would you stand outside while these things happen? Do you have any idea of the potential damage that these things could do to you? If there was a fire in your classroom, how would you respond? I think it's very important that when there is an emergency, a lot of people, they do rehearsals so that if the emergency happens, they don't have to now think, what are we going to do? They're going to respond and react straight away. Unfortunately, in some countries, their kinds of simulations are active shooters, which is very unpleasant. In our country, we always do a fire alarm every now and again, and the kids go and learn to line up and which path to take so that they know where to go. But if there was a fire in your classroom, what would you do? So now all of a sudden, these students get a chance to experience the smoke that would be in the classroom. How would they get out? What about an earthquake in your classroom? So I think you get the idea of how they've taken the arts, designed using mathematics, and now all of a sudden that there is so much in terms of integrating those arts within the maths that I think that definitely the augmented reality is taking the science and the reality and giving you real life scenarios. And of course, that means that we then have to completely adjust those for more realistic situations based on the science that we learn as we progress. And then I wanted to give you one or two other practical examples that have transpired. I don't know how much time I do have, but what I do want to say is that a friend of mine, Mike Soskill, he was basically working on a global collaboration project where his school was connecting with a school in Kenya. And one of the things that they noticed is that when you communicate over Skype and you are connecting with other schools, you often do find that, for example, you learn about their culture, there's cultural exchange. And one thing that they did discover is that the kids struggle to get to school purely because the bridge that they need to walk across had collapsed. And of course, they didn't have any money in the village to build a new bridge. So a lot of those kids were risking their lives trying to get to school on a daily basis. And Mike decided that this was going to be a beautiful way of actually getting his kids to look at bridge designs and what could they possibly do to help the students in Kenya. And they looked at various bridge designs. They looked at costings. There was a lot of backwards and forwards in terms of the measurements and the dimensions. Here they were communicating. They formed teams and groups. They had to then look at the structures and build small models. So they were integrating all of those aspects into their design. And to cut a long story short, they managed to get their designs approved by engineers. And then they fundraised and they got a bridge built for that community. And you can imagine the kind of connection that made. It was a real live, actual example of putting together the collaboration, the arts, the sciences, the engineering, all those aspects. And then, of course, they also learned that those students didn't have access to drinking water, neither did their families. And that went into a whole new project on designing filters and actually finding the most appropriate filters that would work for a village like that, raising the funds and then enabling filters to get to that village so that they had access to actual drinking water. One of my favorite examples of a STEAM-based project was a school that I was teaching at. We're going to be adding a new classroom to the school. And instead of just going the regular route where you go get an architect, you get them to design and build a whole range of different things, and then you're going to get a costing, they decided to put this in the students' hands as a project. And it became a project which overlapped for various different subject areas. So whether it was designing the actual classroom, whether it was writing letters to the local community to ask for funds, whether it was writing letters to the architect for the brief, they actually had to learn how to articulate what it was they needed in this project. And then once they had taken the project, of course, the mathematics and the science. If you were going to paint a classroom, how much paint do you require? How many square meters is this classroom? If you're going to tile the classroom, what sort of choices would you make between vinyl flooring, tiles, carpeting, and maybe just going for some sort of concrete type floor? So they then had to explore and look at the variations and which ones, of course, would add more value to their situation and which ones would last the longest. So they took that entire classroom project and it overlapped on so many levels with so many different areas in arts, science, technology, maths, design. All those aspects were brought into the project. So those are some of those ideas that I wanted to bring to you. I'm going to give you an opportunity to ask questions. And yes, Steve, not everyone is going to agree with me on all levels or any levels, but I am always happy to engage. And not only that, but if there is time, I would love to throw out an activity, a creative activity to end off with today, because Christoph said to me, please, today's the last session of the year, so let's go and do something creative. So I do have a fun little game that we can play. All right. So I do see a question there, and it says here, how do you evaluate the role of philosophy and psychology in maths teaching and STEAM education? I mean, in many places in schools, philosophy is ignored, but it seems that it can help students to see unseen relationships between the elements of STEAM. I couldn't agree more. I would have to say that, you know, when you look at what is being taught in school, we are taking, in many cases, and in fact, this is what I noticed. When the pandemic hit, all of a sudden, schools were forced, they were thrust into teaching online. And then, after teaching online for a year, they came out and said, well, we can now inform you that we are innovative schools because we teach online. Just because you teach online doesn't make you innovative. Online MOOCs and courses have been going for, I don't know how many years. You are not innovative because you can now run a Zoom session in your classroom. What does make you innovative is your approach to teaching. Some schools are introducing music to all their students because they feel that there is a direct correlation between creativity and thinking and mathematics and music. And they feel that every student should learn a musical instrument at their school. Is that the right way? I don't know. Some schools are introducing philosophy to young students. In fact, they are introducing debating to the elementary school students because they feel that learning how to express an opinion, learning how to agree or disagree with someone, those are important skills. So there are so many aspects that you could add to STEAM education to enrich it and make it better. But is there one formula that works? I don't know. I cannot answer that. These are just my opinions and not necessarily what everyone else is doing, because you can go and look at schools around South Africa, and I bump into so many schools where they go, we are the most innovative school in South Africa. And I ask them why? Because every classroom in our school has got a smart board, and we have a projector, and our teachers use the interactive whiteboards. And I said to them, does that make you the most innovative school? Absolutely. Well, you see, then we're going to differ in opinion, because you're still teaching the same way, you're just using modern equipment to teach it. That doesn't make you more innovative. So I do believe that there is space for philosophy. I do believe that there is space for music. I do believe that there is space for play, that a lot more play should be introduced into the curriculum. And I don't just mean at elementary level, I mean at high school level, because I believe that that is where true learning is facilitated. Any other questions that you might? And Steve, if there's something that you do disagree with, I'd love to hear, because remember, these are just opinions. These are not facts. And sometimes engaging with someone, it helps us to learn more about, where we need to develop our own ideas. So maybe I could learn from you because you might have a lot more expertise in certain fields. And I think that is critical, that we are open to sharing with other people, because, I have learned very, very quickly that thinking that you know everything is a very, very dangerous step. And that there's always someone out there that is more knowledgeable. And if they've got something to share, then you should always listen to what they have to say, because it just makes you a smarter and better person. So,
indeed.
Are you unmuted? I think
there you go. Hit the wrong button. Oh, listen, my disagreements with you are more like how much salt do you put on the pizza? They're not big disagreements at all. So don't get me wrong. It's not like what you're saying, but I guess I'm very sensitive to the fact that curriculums are getting so burdened with so many things that people are adding more and more and more and more and more. I've been active in some National Academy of Science meetings, and the amount of teachers are clamoring. I don't have time. I just don't have the time for just endless, and adding the arts is beautiful, and adding this is beautiful, and adding that is beautiful, and it's getting almost. I know in the United States we used to have cartoons making fun of the OSHA, the Safety and Hazard Organization of the government, how they would design a cowboy or a lawnmower and they'd have it so overly built. So whenever I'm an old science teacher, a scientist, a former chemist, and I look at the amount of time that's left on task for things that the science keeps getting squeezed down more and more and more and more, to a point. I know in the United States, where they say now the average elementary kid gets, is it 20 minutes a day of STEM or something, some ridiculously small number? And I say, what are you going to do? Even when you add the arts, So I'm finding myself balking at poor old science, technology, engineering, math, arts. We keep adding things continually, and I don't even know what I'm saying. But that's why
I know exactly what you're saying, because as a mathematician, I see it all the time. Go look at what's happening in California. They're looking at now changing the math curriculum so that it completely eliminates a lot of the math that we used to do at school. And what that is going to do, it means that people are going to be privatizing math education, which means that it becomes inaccessible to a large portion of the population. And that is wrong. And yes, the time to get through curriculum. So let me change your worldview on one aspect.
Okay.
Who's to say that the current curriculum is relevant? So if, for example, we removed aspects of the current curriculum that are not relevant, and when I say integrating the arts, I don't mean that we're adding extra subjects and then we're going to run out of time. I'm saying we take your current science curriculum and we integrate it into project-based learning, where they have to use the science that they are learning, but they also have to integrate it with the arts, which they are doing anyway. So it's more about overlap than to introduce additional content, because the teachers, there's no ways they're going to get through that curriculum if they have to do extra work. And I know exactly where you're coming from, because by the time it gets to the end of the academic year, I'm sitting there thinking 80% of these teachers are now rushing the last 30% of the curriculum because they know that they're not going to get there in time. And how much, what does that do for the students who are getting less quality teaching because they know that they have to get so much information in? I just think that, if I could ask you one question, and maybe this is something that we should ask ourselves. If you look at the jobs that have been around over the past 20, 30, 40 years, and you go look at the jobs that are going to be out there in the next 5 years, most of those jobs don't even exist yet. I mean, if you had told me about being an app developer or writing web software 30, 40 years ago, I mean, those things wouldn't have featured. But now there are so many new jobs that are popping up, and careers, and Bitcoin. Who would have thought that Bitcoin, of all things, would become a massive empire for various people going into business science and looking at finance and whatever it is? The reality is that the world is changing so rapidly that we can't afford to keep thinking what we used to do and then say it still works, because the world around us is changing. And I believe that the people who are evolving from an educational point of view, and I don't mean adding extra, I mean changing what we are already teaching. If we evolve, we can start to match the pace of the world around us, because that is, I think, where the value will be. That we prepare our students to think critically, to problem solve, to be creative, to be able to communicate, to be able to adapt. Because in the new world around us, I mean, just think of the legal profession. You take the legal profession right now. I go to an attorney, there is a 63% accuracy when I get a legal opinion. But if I go to AI that has taken the entire knowledge of legal opinions and put them into one software program, there's going to be a 76% accuracy rate. And now that means I can have access to all the best legal knowledge on one web platform. And I think that that's going to change the legal profession. Of course, I had a legal person tell me, well, that's fine. When those computers start getting it wrong, they're going to come to me and pay me the big bucks to defend you. But the point is that the world is changing. We either acknowledge it and move forward, or we bemoan the fact that there is so much change happening. Education is in a state of flux right now. No one actually knows what's going to happen next year. Are we going back to school? Are we going to be teaching online? Is this the way that education should be taught? Should we be changing the subjects? Can you really effectively teach over Zoom, or do you need to be in the classroom? Should we go back to teaching in the classroom when this pandemic is over? No one knows the answers. But I can tell you that I am absolutely excited about what the future brings in education, because I'm willing to adapt. I've had to. That's what's happened to me. I used to teach in the classroom. Now I'm teaching online. But I suspect that I'll be back in the classroom at some point. That's if Omicron doesn't take over us and make things more complicated. So I don't know if that answered your question, but I do understand your concern with regards to packing in all these new ideas and things into a curriculum that we're already struggling to get through. Maybe it's time to take part of that curriculum out and introduce other parts of the curriculum. Just a thought.
Oh, yeah.
Okay, thank you.
I agree. Sure. Thank you.
Thank you for that question. We're coming to an end of our session now. Did you have a really important question?
Yedidil had a question there.
A quick one then.
Yes, a quick one. I'm from Puerto Rico. I've been trying to develop STEM into the curriculum of Puerto Rico for the last 5 years. I haven't had response and backup from the Department of Education from the island, and also I had contacted most of the university, tried to do an enforcement about agriculture and construction for space for the moons and Mars. And we are so far back behind on thinking point of view that is kind of frustrating on most parts. So I take into my own account to take my personal asset like my grandmother's house, my farm, and so on. I'm gonna do a foundation and do it on my own, even so I got no support. any advice that I can get from the two parties, mostly in South Africa, when they start doing that, if they don't have backup for the government, please.
It's a very good question, and I can answer that very quickly. You know what? There are a lot of people who belong in structures that have never taught before. They've never been engineers before. They've never been scientists before, but yet they will tell you what you need to do to fit into that rectangle that makes education work. And then you get a country like Finland that says, you know what, I think we should do things differently. In fact, let's get the whole government, we're going to throw that shape out and we're going to bring in a whole brand new shape. We don't know if it works because how many years have you been doing it? Only a couple of years. But will the results prove anything? I don't know. I know it's one of the happiest countries according to Facebook, but you never know. Maybe they're just happy and they are learning. But Yadidil, if I can give you any advice, it's become a trailblazer. Start to move forward. Do things that you feel would make and add value. Because you know what I've learned? When people see success, they go, I want to speak to him. I want to be involved with him because he is doing exciting things. And if you bring more people on, you grow the movement. So I do think that there are quite a few people out there. I know that Christoph and the whole STEAM Facebook page, there is a movement of people out there that are looking to grow STEAM, that are looking to add value to education. And you are always welcome to tap in to any of us because we are always happy to do it. Now, I know we've run out of time, and I just wanted to let you know what my plan was because I know we're not going to be able to do it. So in 30 seconds, I was going to ask you all to invent a game. And because I know we don't have time, I'm going to demonstrate what you need to do, and you're going to have to do it yourself. I have actually got over here the link. There we go. I'm going to paste it in the chat for all of you. There we go. There is the link. I'm going to share that quickly with you so that you can actually see what I was talking about. It's called the Inventor Game Grid. And it's something that I put together. Very, very simple to use. Effectively, what you're going to do, and let me see if I can increase the size a little bit. You've got 1, 2, 3, 4, 5, 6, 7 categories. You've got environment, objective, structure, action, roles, equipment, theme. Over here, you've got 10 options. On the bottom, I've put a random spinner so that when you click on the random spinner like this, let's go like this, it's going to spin and give you a number from 1 to 10. The first one is number 9. So what I do is I go into the first one, environment. Number 9 is going to be water. So this is going to be a water game. Then I randomize again, and it lands on number 8. And I go over here and I look at number 8. The objective is guessing. So it's a water game involving guessing. And of course, you keep spinning around and you keep pulling out one from each category. And then you use your creativity to actually design a game that involves water and guessing. So maybe there is a glass, a bunch of glasses of water. Maybe you're in a pool. Maybe, you could start to see how the imagination starts to inspire you. And sometimes when it comes to being creative, you just need to have someone give you a little push. So when Dr. Jan said to them, power and energy, that was just a little push. That opened their mind to a whole bunch of things. So sometimes by inspiring people and giving them a little bit of a push, let them then be creative, and you never know what might come out of it. You might invent a game that has never been invented before, and I look forward to hearing all about it.
Thank you. Christoph called you here a walking steam engine. I thought that was a pretty accurate description. Thank you very much for that presentation, Steve. It was very inspiring, I think, for everyone.
You're welcome.
Even a whole power plant of inspiration. Thanks a lot. And I think this game is excellent. Even in Steve Jacobs' spirit, it can be like a collection of instruments and make an experiment where you use these instruments, what you are spinning out with this wheel. I think that's pretty much Steve Jacobs' inventory here, and that was excellent. And thanks a lot, Steve. It was great to have you here.
Thank you. Thank you for the invitation.
Shall we wrap up then, Chris?
Yeah, I think that brings us to the
maybe
end
Steve
of the
Jacobs wanted to react on that. Sorry, I just see that.
No, it's just that everybody named Steve has a problem. So it's just
okay. It's like Chris, right?
Yeah.
Yes, it's Christoph.
Chris.
With,
yeah, or Park, or Steve, or Chris, and the list is so long. Yeah.
Yes.
We're terminal windbags is what we are.
That's an issue for us. Anyway, we thank you all for coming this month. Are we back again in January? Do we have a date?
Of course. And actually,
wonderful.
We also have some speakers already lined up. So, but let's not tell it yet. Who's coming in January and February? Let's make it as a New Year's surprise. Please tell your friends that this series is going, and please share the link when you get it from our dear colleagues from Sungwo, and let's meet again next year. Let's open this year together. And I don't want to take away the closing from our moderators. I just wanted to mention this. Thanks.
Go ahead, Chris.
I was just going to say, we'll see you in a month or so with a surprise guest. So look out.
Thank you, everyone.
Thank you, Mr. Park.
Bye.
Thank you, Mr. Park.
Mr. Park, yes. Well done.
Thank you.
Thank you, everyone.
Thank you a lot, Mr. Park, for keeping it strong. Yes. Thanks.
Record.